My name is Tan Jun Yu. My number metric is 299,786 and I will solve question 1. Let's start from the question 1a. In statistical hypothesis testing, the null hypothesis HO suggests no significance or effect or relationship between variables maintaining the status quo. The alternative hypothesis HA, on the other hand, proposes that there is a significance effect or relationship which is use statistic analysis to gather evidence and decide whether to reject the null hypothesis in favor of the alternative, indicating significant finding or fail to reject it, suggesting insufficient evidence for the alternative. This process, guided by significance level and statistical tests, is essential for drawing meaningful conclusion from data. For the question 1b, a one-tail test in statistics is used when the research hypothesis specifies a direction of the effect, such as testing if a parameter is greater than or less than a null hypothesis value. It focuses the critical region and p-value calculation on one tail of the distribution. In contrast, a two-tail test is employed when the research hypothesis is non-directional, only stating that there is a difference between the parameter and the null hypothesis value, without specifying the direction of the difference. This test split the critical region and calculate the p-value across both tails of the distribution, allowing for the detection of difference in either direction from the null hypothesis value. What means by a p-value? A p-value is a statistical measure used to assess a hypothesis against observed data. It indicates the probability of obtaining the observed result, assuming the null hypothesis is true. A lower p-value signifies a higher statistical significance of the observed difference. For the question 1d, step 1, we can write H0 population mean equals 6.6 pounds and H1 population mean not equal 6.6 pounds. And step 2, because the question is related equal and not equal, so it is two-tail test and the level of significance is 0.05. And step 3, because the standard deviation is unknown, so it is the distribution. And the n equal to 7, and so the df equal to n minus 1, and df we can get the df equal to 6, and we can use the df equals 6, and the level of significance for two-tail test equal to 0.05. We can get the 2.447 by refer to the student's t distribution. So for the step 5, the sample mean is 7.557 and the sample standard deviation is 1.177, and the both we can either use manual to calculate or can use the calculator to get the answer directly. So for the t, the formula is sample mean minus population mean divide sample standard deviation over square root n. So we can get the answer t equal 2.151. To find t, we must have three information. First one is two-tail test and the df equal to 6 and t equal to 2.151. So refer to student's t distribution graph, t between 0.05 and 0.10. So 2.151 does not fall into the rejection region. H0 is not rejected. The decision for a statistical significance is not changed in average y at both.
Okay, now come to the question 2. Question 2a needs us to list the 5 steps to perform hypothesis test. The first step is state null and alternate hypothesis. The step 2 is select a level of significance. Step 3 is identify the test statistic. Step 4 is formulate a decision rule, and the step 5 is make a decision and interpret the result. Okay, now turn to the next question 2b. The question needs us to find has there been an increase in selling time at the 0.1 significance level. So step 1, we need to state the null hypothesis and the alternate hypothesis. And we will get the null hypothesis H0 is mean smaller or equal to 90 and the alternate hypothesis is mean bigger than 90. The keyword from the question is increase and greater. So we have the alternative hypothesis greater than 90. The next step is select the level of significance. From the question, we know that the level of significance is 0.1. So A equal to 0.1. Step 3 is to select the test statistic. We will use the t-distribution because the population standard deviation is not given. Now come to step 4. It is formulate a decision rule. This step we need to use the t-distribution table. Because of our population is 100, so when we see the table, we need to minus 1. So it's 99 and it is one tail with significance 0.1. So our critical value is in the first column of 99 and it is 1.290. And so we have a decision rule that reject null hypothesis H0 if compute t bigger than 1.290. Now we come to the last step. It is make a decision and interpret the result. From the question, we know that the population is 100, sample mean is 94, sample standard deviation is 22, and the mean is 90. And this is the t-distribution formula, and we put the number that question given into the formula and we will get the answer t equal to 1.818. And we can do the conclusions. 1.818 fall in the rejection region. H0 is rejected. We conclude that this has been an increase in the mean selling time of farm properties. Okay, now come to the question 2C. The question needs us to conclude that the mean salary are greater for the fast food worker than the restaurant worker at the significance level of 0.1 and find the value of P. So let F equal to fast food industry and R equal to restaurant industry. Step 1, we conclude that the new hypothesis is mean F smaller and equal to mean R, and alternative hypothesis is mean F greater than mean R. Step 2 is to determine the significance level. From the question, we know that the significance level is 0.1, so our A equal to 0.1. And step 3 is to select the test statistic. We will choose to use t-distribution. Step 4 is to formulate a decision rule. This step, we need to refer to the t-distribution table. Because our population is 13, so when we refer to the table, we need to minus 2 and we get 11 because of one tier and the level of significance 0.1. So our critical value is in the first column of 11 and it is 1.363. And we can do a decision rule that reject H0 if conduct t greater than 1.363. Now we come to the step 5. It is make a decision and interpret the result. From the table, that question given, we can use the calculator to calculate the sample mean and standard deviation of the fast food and restaurant worker earning. The sample mean of fast food is 142.5 and its standard deviation is 12.24. The sample mean of restaurant is 130.29 and its standard deviation is 15.79. And we put the number into the pool variance equations and we will get 204.094. After getting the pool variance, we put into the two sample test of t-distribution formula and we will get 1.54. And we can make a conclusion that 1.544 in the rejection region. H0 is rejected. We conclude that the mean salary are greater for the fast food worker than the restaurant workers. Next, the question needs us to also find the value of P. So we determine it is one tier and the F n minus 2 is equal to 11 and the T that we found before is 1.54. So refer to the T distribution table and we know that P is between 0.05 and 0.1.
Salam sejahtera lecture and everyone. Today I'm going to discuss the question 3. This question 3 is about the decision for 0.35 significant level. What is the decision regarding the hypothesis that the training was effective improving customer relationships? The keyword is improving. So in this question we need to step out about 5 steps. The step 1 is about the null hypothesis and alternate hypothesis. The H null is mu post less than mu pre. The alternate hypothesis is mu post bigger than the mu pre, because the keyword improving, so that this symbol you need to use that are bigger. So the H null is the value. If your alternate hypothesis is bigger than, then your H null hypothesis is less or equal than. So the step 2, the alpha is 0.05 because the above question is given. And then step 3, use t-distribution because this question does not give the population standard differentiation. So from step 4, we need to draw the graph as usual. Then step down below, which is 0.05 behind the alpha given. So we can find the 0.45 by taking the number of 0.5 minus 0.05, we get 0.45. So we can get the critical value of the t-distribution. We can find that the number is critical value of number is 1.782. We can find this number through the t-distribution table. Now let's move on to the table, which is you can find in the textbook. This is the table of t-distribution. So you can find the critical value of 1.782, which is the significance level is 0.05, and then your DF number is 12. 1.782. So your critical value of t is 1.782. And then move on the next step 5. We need to find the first, which is the s squared p. By using this formula, you can get 33.77. And then this is the t pool t-test, which is this formula. And by using this formula, you can get the answer of t pool test, which is 0.644. And the conclusion is 0.644 for outside the rejection region because it's located outside the 1.782, so that we can reject the null hypothesis. And then we conclude that the training was not improving the customer relationship.
First, we move to the part B. The part B is a partial ANOVA table. There are E5 questions, and then the ANOVA table. First, we need to find the error of DF first, which is we take the 11 minus 2, we get the 9, and then we get the 9, and then we take the 9 multiple 20, we get the 180, and then we take the 500 minus 180, we get 320, and then we take the 320 multiple 2, we get 160, and then we can find the f. We can find the f through by the take the 160 divided by the 20, we get the x. So the f is 8. The first question, first question, how many treatments are there? There are 2 treatments there, because the df of treatment is 2, so that there are 2 treatments there. What is the total sample size? The total sample size is 11, because the total df is 11, so that the total sample size is 11. C. What is the critical value of f? We can find the critical value of f by calculate the df numerator and the df denominator. The df numerator is 2. The formula of df numerator is we take k minus 1, which is 2, and then the df denominator is 9. The formula of df denominator is m minus k, which is 11 minus 3, so that we get 9. The total of df is 11. So we can find the critical value f by using the f table of f distribution. The df numerator is 2, and then the df denominator is 9, so that which the critical value of f is 4.26. So the critical value of f equal 4.26. Then we can reject h no if compared to f bigger than critical f. Then D, write out the null and alternate hypothesis. The null hypothesis and alternate hypothesis is shown is at the mu A equal mu B and mu C, which is the null hypothesis, and the alternate hypothesis is the means are not all equal. E, what is the conclusion regarding the null hypothesis? No, the null hypothesis we can find through the critical value of f, which is 4.26, and 4.26 are located outside the rejection area because the f value is 8. So the 4.26 we can conclude that it falls outside the rejection region, and then the null hypothesis is not rejected. We conclude that the means are all equal. Part C. Use the 0.05 significance level and the 6-step hypothesis testing process to check if there is a difference in the mean flight times among the 3 airliners. So the keyword is difference. So in this part C, we need to state about 6 steps hypothesis testing process. And the first and foremost, step 1, the null hypothesis and the alternate hypothesis you need to state down, which is mu G equal mu J and equal mu C. The G, J, and C you can find in this above table, which is the table of the 3 airlines. We take about the first capital R letter of the words G, J, and C, and then you state down the null hypothesis. And the alternate hypothesis is the means are not equal. And move on to step 2. Alpha equals 0.05, which is you can get in the above question, 0.05 significance level. And move on to step 3. We need to use the F distribution. This is because in this question we are comparing the 3 population, and if more than 2 population we are comparing, we need to use the F distribution. Therefore, we need to use the F distribution table to find the critical value. And then move on step 4. The DF numerator is 2 and the DF denominator is 32. We can find the DF numerator by using this formula k minus 1, which is taking the k value of k, which is 3 population number, and minus 1, which is you get 2, which is the DF numerator, and then the DF denominator you can calculate by using this formula n minus k, which is the total number of the 3 population numbers airliners, which is you get 35 minus 3, and then you get 32, and you get these 2 information. Therefore, it indicates that you can find the critical value f by using the table of f distribution. Then you go find the f table distribution, and in this, make sure the alpha is 0.05, double confirm it, and then you can find the critical value in this table. The DF numerator is 2, and then the DF denominator is 32, and then you can find that the critical value is in this table 0.03, and then move back. We can state that the critical value of f is 0.03, and we reject h no if compared to f bigger than the critical f. Move on to step 5. We need to state down the ANOVA table, and you need to complete it. There you can find write down the treatment and error. So first we need to find sum of squares of the treatment and the error. You can find the value of sum of squares by using the formula, and then you get the value of treatment is 53.496, and then the sum of squares of value of error is 728.723. In the total number of sum of squares is 782.219, and then the TF number of treatment is 2, and then the DF of error is 33, and then you get 35. Then the mean squares of treatment you can get by taking the number 53.496 divided by 2, you get 26.75, and then the mean squares of error you can get by taking number of 728.723 divided by 33, you get 22.08, and then finally the F you can get by taking number of the mean squares of treatment and error, which is 36.75 divided by 22.08, you get 1.21, which is the value of F. And then move on to step 6. 1.21 falls outside the rejection area, so that we can conclude that the null hypothesis is not rejected because the 1.21 is outside the critical value of F 3.30, and then we conclude that the null hypothesis is not rejected. We conclude that there is no difference in the mean flight times among the 3 A liners.